Hey guys, today we're going to be talking about multiplying a binomial and a trinomial. So you can see right here I have 2x plus 5 listed. That's our binomial. And it's multiplying 3x squared plus 7x minus 8, our trinomial. And we want to figure out, how does this work? Now we've talked about multiplying binomials before, and we discussed how you can use the mnemonic device FOIL to help you distribute all of those numbers. But FOIL only works when you have two binomials. What do we do here? Because first inside, outside, last doesn't quite cut it whenever we have three terms. Well, the answer is actually pretty simple, and it's based around still the idea of what we do with binomials, about how foiling is just a easy way to remember the distributive property. The distributive property says that if we have multiple terms multiplying, well, anything, then as long as we multiply each term by every other term in what it's multiplying, we're good. So what we're ultimately going to have here is 6 instances of multiplication. We need to take this 2x and multiply it by all 3 terms, or distribute it into all 3 terms. We do the exact same thing with our second term in the binomial, this positive 5. It too is going to multiply all 3 terms, just like that. We are going to multiply 6 different sets of numbers and then put all of those together into one expression. So let's see exactly how this is going to work. Let's get some practice. The 2x is going to multiply our 3x squared. 2x times 3x squared, well, 2 times 3 is going to be 6. And then x times x squared gets us x to the 3rd. Then we need to multiply our 2x by our next number. 2x times 7x. Well, 2 times 7 is 14. X times x is x squared. And finally, 2x times negative 8. 2 times negative 8 is negative 16. And there's only one x here, so it's just going to stay x. Let's take a look at our second half. 5 times 3x squared. 5 times 3 is 15, and then we have x squared there, but no other variables, so it stays the same. 5 times 7x, 5 times 7 is going to get us 35, and then again, we just have that single x that's going to stay with it, and then we end with 5 times negative 8. 5 times negative 8 is going to get us negative 40. So we have a really long expression here, but there's probably something we can do with it, right? We can combine like terms. You'll notice several of our terms have matching variable configurations. Let's start at the beginning. Do we have any matching variable configuration for 6x to the 3rd? No, we don't. We only have one x to the 3rd variable, so it's not going to change. So I'm going to keep it just like it is. Next up, we can look at our x squared term. We have positive 14x squared. Do we have any other x squareds around? Absolutely. Positive 15x squared. So positive 14 and positive 15 are together going to make 29x squared. Next up, we have negative 16x. Do we have any other x's? Right here, positive 35x. So we have negative 16 plus 35. I hope my math isn't off, but I think that's 19x. And then we notice we have one last term that we haven't underlined or anything yet, negative 40. That doesn't have anything to combine with because there's no other numbers without a variable. So it stays the same here at the end of the problem. Now there is a couple things I want to mention. First off, being we want to write this in order of descending degree for each variable. So regardless of the order you combine your like terms with, even if you started with 14x squared or you started with negative 16x, whatever you may have done, we want to write this in order of x to the third, x squared, x constant. You've probably heard me say that many times, but it's always worth repeating that whenever we write an expression fully simplified, our standard way or kind of our accepted way of writing it is by descending exponents. The next thing I want to mention is that after we multiply these, it is really important we keep that sign with them. We're effectively just creating a long expression of multiplication here. So we want to make sure that whenever we got a positive 14, we write that plus with it. We don't want to just have 6 different numbers here. We want to keep those signs so that we make sure we combine them properly. If you have any questions about this, feel free to drop them below. I'll be more than happy to get to them as soon as I can. Otherwise, we are going to have a second video going over some further examples of this process. You can check it out if you're having any difficulty or if you'd like to just see some more examples. Thanks for watching, guys.